Good day, everyone. I'm Arvin Enriquez, your subject teacher for probability and statistics. With this video lesson, our topic is about understanding the C scores. Our lesson objectives: at the end of this lesson, you are expected to relate a random variable distribution to a normal variable distribution. Understand the concept of the C score. Convert a random variable to a standard normal variable and vice versa, and solve problems involving random and normal variables. For our lesson introduction, C-score is stated to be a measure of relative standing. So when we say measures of relative standing, in the statistical sense, can be defined as measures that can be used to compare values from different data sets or to compare values within the same data sets. That's why we use C-score to represent, for example, scores in exam. So how can we assess this data, or how can we represent this data using your C-scores? So these C-scores will represent scores of our students based from their exam. So how many students are above average? How many students are average? How many students are below average? And that will be the question now. That's why we are using C-scores to represent those scores. Or in each C-scores that we have, there is a corresponding value that we can get from this. That's why using your C-scores, we can actually describe the behavior of the scores of our students based from their exam. Next statement is that these scores represent distances from the center measured in standard deviation units. So we said on our last video lesson that your standard deviation will define the width of your normal curve, meaning to say it represents the uh, the difference, no, the differences between your scores under your normal curve. It defines the width of the normal curve. Next statement: there are 6 C-scores at the base of the normal curve. So there are only 6 C-scores allowed in every normal curve. 3 C-scores to the left of the mean, meaning to say these are negative C-scores. There are 3 negative C-scores and 3 C-scores to the right of the mean. So these are positive C-scores. So there are only 6 C-scores allowed in every normal curve. There are 3 negative C-scores and 3 positive C-scores. As a part of the continuation of our discussion points, we're talking about, again, with your C-score, the areas under the normal curve are given in terms of C values or C scores. Either the C score locates X within a sample or within a population. So there are cases that your X is within a sample or within a population. Here are two formulas for calculating C. It depends on the given values. Again, if your given value is your population mean and your population standard deviation, then we're going to use your C formula for population data. Now, if the given are the sample mean and the sample standard deviation, we're going to use the C formula for your sample data. So we're going to use these two formula, and it will be dependent on what will be the given on the problems that we are encountering. Now, for your first formula, which is your C is equal to your X, this will be your raw score. This will be your given measurement. X will represent the given measurement. Then your mu here is your population mean. Then your sigma in your denominator here is your population standard deviation. Again, if the given are the population mean and the population standard deviation, we're going to use your first formula. In your second formula, X is still your raw score. For example, if there's a given values of your scores from the exams of your students, then you are looking for the value of your raw score, so that will be your X or the given measurement. Now, if your X bar will be your sample mean, then your S here in your denominator will be your sample standard deviation. So if that is the case, if the given are the sample mean and sample standard deviation, then we're going to use your second formula or your C score for the sample data. So these are two formula in calculating your C score or C value. So these two formulas will be dependent on the given values on the problem that we're going to encounter. If that is a population mean or a sample mean, if that is a population standard deviation or a sample standard deviation. It depends on the given values. So you need to look or you need to assess the given values before you come up with the idea that you're going to use this first formula or this second formula. In using these two formula, you need to assess first the given values. Again, for the continuation of our discussion points, for any population, the mean and the standard deviation are fixed. Dealing with any population, there should be a fixed value of your mean and your standard deviation. Thus, the C formula matches the C values one to one with the X values or raw scores. That is, for every X value, there corresponds a C value. And for each C value, there is exactly one X value. So there is a one-to-one relationship between your X value and your C value here. One C value for only one X value or one X value for only one Z value. Another continuation of our discussion points, the C values are matched with specific areas under the normal curve in a normal distribution table. So last time, we used your C table for us to find the area that we're going to map to each C values that we had in your examples in the last video lessons. Now, therefore, to find the percentage associated with x, we must find its matched C value using the C formula. Now, last time, there's a given value of your C, but in our case, now, we're asked to find the value of your C by simply using your population mean, your sample mean, your population standard deviation, your sample standard deviation by simply using these two formulas that will be dependent on the given values from the problems that we are encountering with this video lesson. Now, in each C value from the C table, there is a corresponding value of areas under to our normal curve. So if we multiply this area by 100, this will be the probability. So therefore, we can say that the area under this normal curve will represent also, or that will be equal to a probability that will be mapped to each C scores that we have. Now, that's why to find the percentage associated with the X, we must find its match C value using the C formula. Now, if that is the case, if the given are your population mean, your sample mean, your population standard deviation, your sample standard deviation, then that's the time that we are using these two formula for us to compute for the value of your C score or scores. Then using your table, we're going to find, or we can find now the value of area that will be mapped in each C score, or the resulting value that we get from the C formula that we use. Next, the C value leads to the area under the curve found in the normal curve table. So that is the statement that I said before, no, a while ago. Again, using your C table, if there is a given value of C, or if there is a given a resulting value of C, then we can actually find the area that will be mapping each C score that we are computing, or from the given value of C, which is a probability. And that probability gives the desired percentage for X. That's why this area under your normal curve will also represent your probability or probabilities that will be mapped in each C value, or in each C computed values, or in each C score being given in the problem. So we just simply multiply this area under your C table by 100, and that will be the probability or the percentage or the desired percentage for that X, or what we call the given measurement or the raw score. For example, if we're talking about the scores from the exam of our students. For example, number one, for us to visualize more, uh, what will be the use of these two formulas for, or in computing for the value of C with the given value of your population mean, your sample mean, your population standard deviation, and your sample standard deviation. So with this example number one, so there is a given value here which is your population mean, which is your mu, that will be equal to 50, and the standard deviation sigma, which is equal to 4. So these two values are from a population of reading scores. So find the value of C that corresponds to a score which is X is equal to 58. So your X is equal to 58 now is your raw scores, or the given measurement in this problem. Your first step is that you need to look for the formula that you're going to use. It depends on the given values, if that is a population mean or a sample mean, or a population standard deviation or a sample standard deviation. But in our case, with this example number one, the given are your population mean and your population standard deviation. So we're going to use your first formula with the two given formulas a while ago. For your second step, check the given values. Since these are population values, the C-score locates X within a population. Meaning, say your raw score here, or your X that will be equal to 58, is from within a population, because the given is your population mean and your population standard deviations here, which is your sigma. So with a given value, your population mean is equal to 50, your sigma or your population standard deviation is equal to 4, and x, or your given measurement, or your raw score, is equal to 58. Then for step number 3, you're going to substitute the given values in the computing formula. So we just simply substitute this population mean, your population standard deviation, and your x, which is equal to 58, to your first formula. So that will be 58 minus 50 over 4. So 58 minus 50 is equal to 8. Then we copy your denominator, which is equal to 4. Then 8 divided by 4, that will be equal to 2. Now, for your step number 4, compute the C value. We are just simply simplifying, no? Right after substituting these given values to your first formula and computing your C, then we just simply simplify this. We just simply simplify your numerator and denominator. Then the resulting value for your C is equal to positive 2. Thus, the C value that corresponds to the raw score, which is equal to 58, is 2 in a population distribution. So here is the value of your C that can be mapped to your 58 here as your raw score. So as part of our solution in example number 1, this conversion from raw score to C score is shown graphically. Now, since the computed value for our C that will be mapped to 58 as your raw score is equal to 58. So here is your 2 now as your C score, and your 58 as your raw value that will be mapped to your C, which is equal to 2. If you try to look with this normal curve, so there are 3 positive C scores here, and there are 3 negative C values here from the left of your mean. Then from our description with your normal curve, your mean, median, and mode will coincide at the center. So I mean to say, we're going to put your 50 here as the value of your population mean. This will be the given value for your population mean. So we need to put here at your 0. Now, if that is the case, no, if you try to look with this one, there are 2 units, or 2 units as a difference, no, between your 0 and 2. So this will be your first unit and your second unit here. Now, if you try to look with this 50 and 58, so in your 50 and 58 now, no, so there is an 8 units as part of their difference. Now, if we divide these 8 units, no, as the difference between your 50 and 58, since there are 2 units here from 0, or your C is equal to 0, then your up to your C, which is equal to positive 2, so there are 2 units here. So what will be the median from this 50 and 58? So if we divide these 8 units from 50 to 58 by 2, so that will be 4. Now, we're going to add 4 from your 50 going to the right. So 50 plus 4, so that will be 54. So that's how we get your 54 here. Now, going to the right of your 58, so 58 plus 4, that will be 62. Going to the right, so we're just subtracting 4 from your 50. So 50 minus 4, that will be 46. 46 minus 4, that will be 42. Then 42 minus 4, that will be 38. So these values is based from the difference between your 50 and your 58. So the differences between these scores that we map to each value of your C score will be dependent, no, on the given values. That's why you need to assess for us to visualize more what will be the value that we are going to map in each C scores that we have in this normal curve. Now, if we try to observe, your 50 here as your population mean will coincide at the center. Then from the diagram, we see that a C-score X is equal to 58, or your raw score, which is equal to 58, corresponds to your C, which is equal to 2. It is above the mean. So we can say that with respect to the mean, the score of 58 is above average. So I mean to say, since your 50 is your population mean and 58 is greater than 50, we can say that 58 is above average. For example, number 2, we're asked to locate the C value that corresponds to a phi score of 39, meaning to say this 39 will be equal to your X or your raw score. Given that your population mu is equal to 45 and your population standard deviation sigma is equal to 6. Your step number 1. So you need to assess first your given values. That will be your population mean and your population standard deviation. Now, therefore, we're going to use your first formula in computing the value of your C. For number 2 or step number 2, check the given values. The C score in question locates X in a population mean. Since your given value or values, I mean, no, is your population mean and your population standard deviation, meaning to say that your X or your raw score is within a population. So here, your mu is equal to 45, your sigma is equal to 6, and your X is equal to 39. We just simply substitute the given values to your first formula in computing the value of your C. So that will be your step number 3. Going to your step number 4, we're asked to compute for the value of your C by just simply simplifying, no, your step number 3. So if we simplify this one, now 39 minus 45, so that will be equal to negative 6. So we copy your denominator. So negative 6 divided by 6, that will be negative 1. Thus, the C value that corresponds to the raw score, which is equal to 39, is negative 1 in a population distribution. So a negative value of C, meaning to say, if this is your normal curve, and if this is your mean, which is 0 here, no, as your C score, then your negative value will fall on the negative part of your normal curve, or from the left side of your mean. So meaning to say, this negative 1, that will be mapped to your 39 here, since your mean or your population mean is 45, no? With respect to the mean, the score is 39 is below the population mean. We can also say that the score 39 is below average. Why? Why is that it is below average? Because your 45 here, no? 45 is your population mean. Then if we're going to map your 39, will be here in the left side of your mean. So that will be the negative part of your normal curve. So in reality, 39 is less than 45. Or we can say that 45 is greater than 39. So we can say that 39 is below average because your average score or your population mean is 45. That's why your 39 or the score 39 or your raw score 39 is below average. For activity number 1, state whether the C-score locates the raw score X within a sample or within a population. In the part 1 of your activity 1 with this visual lesson, you're not going to compute for the value of your C. You just simply ask to state whether the C-score locates the raw score X within a sample or within a population mean. So Your answer will be within a sample or within a population. A while ago, I said that your X or your Roy score is within sample or within a population will be dependent on the given values. Oh, so if the given values are your population mean and your population standard deviation, meaning to say your raw score or your X is within your population. If the given values are sample mean and sample standard deviation, then your raw score X is within your sample population. Again, for part 1 of your activity 1, you just simply state whether the C-score locates the raw score X within a sample or within a population. Your answer will be within a sample or within a population. You don't need to compute for the value of your C. For part 2, so this will be your part 2 and this will be your part 1. In your part 2, given your mean or your sample mean, no, which is equal to 62, and your sample standard deviation 8, find the C-score value that correspond to each of the following scores up to 2 decimal places. Now, you're going to use what formula between your two formulas being given in computing your C. Now here, the given is your sample mean and your sample standard deviation, meaning to say you're going to use your second formula in computing your C value or your C score. So here, there are raw scores here as your given value. For each raw score, there is a corresponding C scores. That's why we're going to compute for the value of your C using your sample mean and your sample standard deviation and these 5 raw scores. So your answer is up to 2 decimal places. So you need to round up. So as part of our summary, the importance of the C-scores. Raw scores may be composed of large values, but large values cannot be accommodated at the baseline of the normal curve because in every raw score, there is only one C score. So there are 6 C scores allowed in every normal curve. So there are 3 positive C scores at the right of your mean and 3 negative C scores at the left of your mean. So they must be transformed into scores for convenience without sacrificing meanings associated with the raw scores. So we're just simply substituting raw scores for us to describe the behavior of your scores. For example, the scores of your student from their exam. So we're just simply substituting or we just simply consider only your raw scores, but not all scores from that particular exam. Thanks for watching. Like, comment, share, and subscribe.